Hey everyone, welcome back to my channel EduVibe. In today's lesson, we'll start doing the another topic of the electromagnetic radiations, which is the we're doing the small and the approximation. This is grade 12 physics, and this is a topic which is related to the previous topic, which is the diffraction and the interference. We do the Young's double slit experiment. We're doing the formula like this, and this small and approximation will give you the another formula for this to calculate this, a shortcut way to do that formula. So small and approximation, we consider the same diagram, we consider the same terms like we do L, we do D, we have a theta, we have H, we have that maximums. So if our angle is very small, it may be challenging to measure. So in fact, it is a much easier to measure the ratio of this, which is H upon L. You can see the ratio for this angle is going to be H upon L. So from the diagram, if we can also be seen the tan is equal to H upon L, which you must know. So for small angles, usually theta if is less than 10 degrees, then theta is equal to the sine theta. This gives an small approximation. So basically, if the angle is given to you and if it is a less than 10 degrees, so you can firstly use that thing to calculate that if your angle is less than 10 degree or not. If your angle is less than 10 degree, so you can use the small and approximation formula instead of the general formula, which is that. So you can directly use that formula. That formula is more convenient than this because this will not involve the angle, because angles are already defined if it is less than 10 degrees. So you can use directly this formula. If not, so you can use the general formula as you can. So firstly, you have to check if you have angle now. You can't rely on that formula. You rely on that formula if you want. But you firstly have to check the angles. The above equation may only valid for the less than 10 degrees. If the angle is written at 10 degrees, you must use the equation that involves the sine of the angle, which is that. So this means that for any problem involving diffraction, before you use a simplified equation, check the angle. So if theta is less than 10 degrees, use the small and the approximation formula. If not, to go with the general formula. So that's all you have to do. And this is very important to know because we are doing that thing again and again in upcoming lessons now. And in the previous lesson too. Now you have to check the angle. You have to do that thing when you do that things. So we have example over there. Let's see that what example says. So if in an experiment a student is using monochromatic light with the wavelength of 550 nanometers to study the effects of the diffraction using double slit apparatus with the spacing between the slits of 2.50 10 raised to minus 6 meters and the distance between the slits and the screen is 0.0750 meters, determine the distance between the central maximum and the first order bright fringe. So now you have to know this whole diagram in your mind, because they mention, not directly mention, that this is n, this is l, this is wavelength. So you have to know that what they're talking about. If they're talking that distance between the central maximum and the first order bright fringe, so you have to know that they're talking about the x. So in this you have to find the x. You have n, which is like they mentioned that first order bright fringe, so this is 1. Wavelength you have 550 nanometers. They mention that distance between the slits and the screen is this. So slits and the screen's distance is called the L. You can see these are the slits, and this is your screen. So the angle between them is L. So basically the L is given to you. So L is 0.0750 meters. And the other thing, which is the spacing between the slits, is your T. 2.50 10 raised to power minus 6 meters. So firstly, you have to check the angle. How can you check the angle? Because you can check the angle by doing this. Tan theta is equal to h upon L. So from this you can check the angle, but you don't have h. H can be fine. So you can use your general formula to find the angle. So Sine theta goes over there. You can get the theta is equal to sine minus 1, and you have with n times wavelength upon d. So sine minus wavelength, so this is 1. Wavelength is 550, nano has 10 raised to minus 9 meters. Divide this by the d you have 2.50 to 10 raised to power minus 6 meters. So what's the theta? So when you calculate this, make sure in degree mode, you get 12.709 degrees, and this is your answer. But this is this is not greater than less than 10 degrees. You cannot use a small-angle approximation. So if you want to find the x, so you can find that formula because this has the x value in. So x theta has the value of 12 degree, 12.70.9 degree something, and you have to multiply this by L, which is 0.0750 meters. So when you put this in, you calculate, you solve it, and you get 0.0169 meters and 0.0169 meters, you can see. So this is your answer. So in this question, we're going to use this small-angle approximation formula because the angle is not less than 10 degrees, it's greater than 10 degrees. So that's all you have to do. But you can use the tan theta formula because you have another formula for calculating the F, calculating the F. But this is the thing you have to do. We will practice that questions too, where we have to use a small approximation in our practice questions. So that's all for this lesson. This is such a short lesson. We have to just know about this method. And now we are dealing with the last topic of this part, of the diffraction part, which is the important topic, which is the diffraction gradients and the polymerization. We are doing that topic in the next lesson. So learning with EduVibe, learn smarter, not but harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till I say get it with EduVibe.